All right, so here we have the instantaneous rate of change. So for y equals f of x, the instantaneous rate of change of x at a is the limit of h goes to 0 of f of a plus h minus f of a over h if the limit exists. All right, so we saw that in our previous example, and we had to figure out what the instantaneous rate of change was, and that's what we did. We did the a plus h minus f of a all over h. Then we took the limit as h goes to 0, and that gave us the instantaneous rate of change. Now, the adjective instantaneous is often omitted with the understanding that the phrase rate of change always refers to the instantaneous rate of change and not the average rate of change. Similarly, velocity always refers to the instantaneous rate of change of distance with respect to time. So those are kind of some little nuances that we kind of need to remember. Now, let's say a line that intersects a circle in 2 points. We should remember that that's called a secant line. So that's going to intersect here and here. So that's a secant line. And a line that intersects exactly 1 point, which is going to be that one, the red one, it intersects at only 1 point, and that's called the tangent line. Now, our slope of the secant line can be found by taking y2 minus y1 over x2 minus x1, which gives us this, which guess what? Gives us the difference quotient. And so for the slope of the secant line, we just use the difference quotient and we can find that. And so the difference quotient basically is interpreted as both here. Now the key is it's both the average rate of change and the slope of the secant line. So it gives us both of those items, okay? And so that hopefully will help us here with the next one. And so here we're given f of x is equal to x squared. We're supposed to find the slope of the secant line for a equals 2, h equals 2 and 1. So we're going to be two things there. And we're going to find the simplify the slope of the secant line for a equals 2 and h at any non-zero number. And then we're going to find the limit of the expression in part 2. And then we're going to find the slope of the graph and the slope of the tangent line at a equals 2. All right, so quite a few things. First off, we need to find the slope. So slope is just represented usually by m. And so we're going to do a is 2 and h is 2 first. So we're going to do these two first. And remember, it's going to be f of a. We're going to use this formula here. We're just going to do 2 plus 2, and then that's going to be 2, and that's going to be 2. So doing all those, we're going to have f of 2 plus 2 minus f of 2 over 2. And so that's going to be f of 4 minus f of 2 over, let's put our minus so we can see it, and 2. So f of 4, so that's going to be 4 squared, so that's going to be 16. And 2 squared is going to be 4, and then it's over 2. 16 minus 4 divided by 2, that's going to give us 6, it's going to be 12, so it's going to be 6. Okay, so that's our slope of the secant line with a equals 2 and h equals 2. Now let's do it for a equals 2 and h equals 1. Okay, so same thing. Now we're going to do f of 2 plus 1 minus f of 2 over, now we're doing over 1. So f of 2 plus 1 is going to be f of 3 minus f of 1 all over 1. F of 3, well, 3 squared is 9. F of 1 is 1, and then divided by 1. So 9 minus 1 is 8. Oh, wait, that's 2. I can't read my own writing. And so that's going to be a 4. And so then 9 minus 4 is 5. Divided by 1 is equal to 5. All right. So that's going to be what our slope is when we have, again, a as well, 2 and the h is 1. Now 2, we're supposed to find and simplify the slope of the secant line for a is 2 and h is any non-zero number. So basically, we're just going to keep our h in there. And so when we do that, we're just going to use the h instead of the 1. So we're going to basically have m, we're going to find the slope, and that's going to be f of, now we want a is 2 plus h minus f of 2 all over, and again, we're just going to use h. All right, so we're going to plug in 2 plus h into here, so that's going to be 2 plus h squared minus, well, we plug in 2 in that, it's going to be a 4, and that's all over h. Now we're going to square that, so it's going to be what? H squared plus 4h plus 4. So we rewrite that as h squared plus 4h plus 4 minus 4 over h. Well, that 4 cancels that 4. That h cancels that h, and it cancels one of those h's. And so it looks like we have h plus 4 here. And remember, h cannot equal 0 because we can't divide by 0. All right, so that's going to be what 2 is. We just get h plus 4 as our slope. Well, what about 3? Find the limit of the expression. Okay, so, well, the limit as h goes to 0 of h plus 4 is going to be what? Well, that's just going to be 4 because we plug in 0 here and we get 4 left over. Now, we had talked about a little bit ago that the difference coefficients, average rate of change, and the slope of the secant line. And so the slope of the graph and the slope of the tangent line, what those are going to be for the slope of the graph is equal to the limit of the slopes of the secant line, limit of the slope of the secant line. And, well, we found the limit of the slope of the secant line. That was equal to 4, so that's equal to 4. And this is also the tangent line. Okay, so that's also equal to 4. So both of those are going to be equal to 4 in this case. All right, so let's stop there and we'll come back in a little bit for more.